So we're going to start on the probability chapter 2 today. And this activity, I'm just going to do one activity on here, partially because I'm going to have to rotate the screen differently, which I haven't got the technological knowledge to rotate part through a video based on how I've got it set up. But also just because this is a really nice activity, not just mathematically, but for mindfulness as well, because you can be as colourful as you wish and as nice as you wish in terms of what you do. I've got a whole range of colours. The colours do not tell me anything other than the fact that I fancy using different colours. And it's a good revision resource that you can make yourself, reminding you of different probabilities and what they mean on a Venn diagram. So it's a refresher of set notation and what parts of Venn diagram tell us. So I've provided this resource for you. Now all of the circles need to be labelled A and B so that it makes sense when we are writing our notation. So something like this. Now I've actually only got 8 Venn diagrams on the side, which I know is really irritating OCD wise, given that we've got 9 on the diagram. If I can think of one that we haven't done at the end, then I will. So the first one is, so it's always the dark green part that we're looking for. So it's got all of the circle labelled A, including the overlap part, shaded in. So I'm doing it with a really sort of light shading. Oh, I've gone over the lines. Oh, that makes me feel a little bit sick. It's fine. You can colour it in with a highlighter pen or whatever it is that you want to do. But effectively the whole of A is shaded in. So what this diagram would tell us is the probability of A. Now you can label it next to it. Obviously I'm trying to fit it all in within this camera rather than writing it within the circle of B. Obviously we're always talking about the shaded in part. So the second bit on the diagram, quite obviously I would say, shading in all of circle B. Is obviously going to be the probability of B occurring. So all of that circle would be the probability of B occurring. So our next one is, what colour do I want? Pink. So it's the entirety of the 2 circles coloured in. So this is the probability that either A occurs or B occurs, or both, but one or the other occurs. So we say that's the probability of A union B. So in words, this is either or. So it doesn't matter which one occurs, doesn't matter if both do, as long as at least one occurs. And that's the probability of A union B, which translates as either or. The next one, colour I don't like so much, green, I don't really like green so much, is this bit in the middle, this overlap part. So we call it an overlap, or we can call it intersection. So that bit in the middle is the probability of A intersection B. So that means both. So both things have to have occurred for that in the middle. And we write it as intersection A intersection B. The next part, oh, I've lost track of what colours I've used, is everything coloured in except for the circle A. So everything's coloured in except for the entirety of circle A. So when that happens, this is the probability of not A. So it's the probability that A doesn't happen. We sometimes call this A complement. We might also call it A dash, but it means A not happening. And obviously the probability of A not happening plus the probability of A happening is 1, which you could see if I took this circle and coloured it in, it'd be the entire thing that is coloured in. The next one is not a repeat, like we did up here. So it's everything coloured in, including the overlap, but not B only. So we can't describe this as the probability of not B, because B can occur, but it only occurs when A happens. So this would be the probability of B complement or A. So I could have written this as the probability of A or B complement. Doesn't matter. So B doesn't happen, or A does. So that's why this overlap counts, because A does happen here. So A can happen, or B doesn't happen. So out here, B doesn't happen. Here, B doesn't happen. Or you could call that as A happening. Here, A happens. So we can accept the probability in here, because either B doesn't happen or A does. One of those things must be satisfied. Doesn't have to be both. One of those needs to be satisfied at least. Here, one of those is satisfied, A happens. Here, one is satisfied, B does not happen. Here, actually both are satisfied. Okay. Here we have, oh, which blue did I not use before? I think the light blue. 1, 2, 3, 4, 5, 6, 7. Gonna have to repeat the colour, sorry. The 7th one, only the section of A, which is A on its own, is shaded in. So it's only this crescent part of A is shaded in. So we can't just say it's the probability of A, because this would be the probability of A as well. So this is the probability that A does happen, but also B absolutely does not happen. So A must happen and B cannot happen. So if we're looking at B cannot happen first, that's everything except for this circle. And also A must happen. So we're only looking within this within this crescent. A has to happen and also B does not, which is why we're not including that part. So final one in the PowerPoint is, actually I didn't mind the green. So I'm going to use the green again because I didn't use it very much to start with. And this is actually not a bad green. I have a slight aversion to green because my old school uniform was green. So I really did not like green as a colour, but this is actually quite a nice green. So it's all of this outside part. So I would probably choose to write this as not A or B. So neither A nor B. You can also write this as not A and not B, or not A intersection not B. So that means A does not happen and also B does not happen. Or it is not A union B. Either of those acceptable, it's just looking at the different context of the colour. Is there anything that I haven't included that I could in the final one? I don't think there is really. I thought of one, but I don't think I did. But what is useful that I can do on the last one is that we call a full set with this little funny E. This is actually, I think it's epsilon from the Greek alphabet. It's like if I draw it bigger, it's like I'm drawing an E with the overlap in the middle, obviously a sort of weird capital E, there's a curvy E. That means the universal set, which basically means all the numbers included in a set. So if you were looking at a 52 card deck, for example, the universal set would be all 52 cards, which is why we always draw a box around Venn diagrams, because we're showing that everything involved is contained within this box. So yes, I don't expect yours to be quite as rushed and as mucky as this is. I'm particularly disappointed with this bit. This makes me a bit sad. But you can do yours really nicely and really neatly. You can use whatever colours you want to. And yeah, just have some fun. Have a little bit of mindfulness while doing something that is potentially mathematical and helpful. This is a really good resource when you're doing Venn diagrams. Just have to the side while you're doing Venn diagram work. And even if not, if you make it nicely, it's quite pretty to look at while you are doing stuff. So next video will be actually looking at using universal set notation and then moving on to conditional probability with Venn diagrams.